Okay, so today we're not really going to have notes, we're going to have examples that we're going to do together. We're going to take a table of information from an equation, we're going to create the table of data, and then we're going to actually design a graph. So our first example is Zinn is buying beverages for a party which are individually packaged and come in packs of 8. Let T be the number of packages Zinn buys and B be the total number of beverages. The equation T equals 8P can be used to calculate the total number of beverages when the number of packages is known. Determine the independent and dependent variable in this scenario, then make a table using whole number values of P less than 6. So they've already filled in part of the table for us. Number of packages P, they start with 0, 1, 2, 3, 4, 5. Those are numbers less than 6. And now we need to apply the formula or the equation T equals 8 times P in order to get the number of beverages. So if the P is 0, 8 times 0 is 0, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and 8 times 5 is 40. Those are your values in your table. From that table of information, we are going to create the graph. Remember, graphs need labels on both sides, on both axes. And down here, I'm going to put the number of packages. And this will be my x-axis, and that will be my independent variable. And then up along the y-axis, we will have our number of beverages. And that is my dependent. In addition to titles, we also need some numbers. So where the x and the y-axis intersect, that will be my 0. And the number of packages will 1, 2, 3, 4, 5. You can include that 6. And then I will skip count by 8 for my graph. Okay, so my first point was at 0, 0. Then I was at 1, 8. 2, 16, 3, 24, 4, 32, and 5, 40. And there's my graph. Looking back at my table, this was my x value, this was my y value. Next example, use the graph to determine which variable is the independent variable and which is the dependent variable. Then state the relationship between the two quantities. Okay, so our x value is always going to be our independent variable, so the number of hours here is the independent variable, and this will make the number of miles the dependent. And what this graph is saying is that the number of miles depends on the number of hours. One last one together. Each week, Quentin earns $30. If he saves this money, create a graph that shows the total amount of money Quentin has saved from week 1 through week 8. Write an equation that represents the relationship between the number of weeks that Quentin has saved his money and the total amount of money he has saved. Then name the independent and dependent variable. Write a sentence that shows this relationship. Okay, so we see some key things here. We see that he has $30 each week, and that we are looking at weeks 1 through 8. We've got our S for our saved money and our W for our weeks. Okay, so we're going to want to label our grid, number of weeks, and that is our W. Then we have our S as total saved. And based on the information, we're saving $30 per week. So the formula or the equation here would be S equals 30 times W. Number of weeks, they told us that we wanted to go for the weeks 1 through 8. And then I'm going to do the math in the equation. 30 times 1, 30 times 2, 30 times 3, 30 times 4, 30 times 5, 30 times 6, 30 times 7, 30 times 8. Our independent variable are the weeks, and our dependent variable is the money saved. The money saved depends on how many weeks. Taking the table of information and creating our graph, putting labels, we have number of weeks on our x-axis. We have the number, we have money saved on our y-axis. We're going to put some numbers here. Our graph doesn't seem big enough to accommodate the 8 weeks, but we will just go with 6 weeks. And then we're going to go up, counting by 30s. And again, our graph does not accommodate everything that we have in the table. That's okay. We are not going to put anything at 0 because none of our weeks were at 0. We're going to start right with 1 and 30, 2 and 60, 3 and 90, 4 and 120, 5 and 150, and 6 and 180. And our sentence would be, money saved depends on number of weeks. And that's how you take a word problem, translate it into an equation, fill in a table, and make it a graph from the table.